The term pixel is actually short for picture element. These small little dots are what make up the images on displays. Every pixel in an LED display is comprised of 3 diodes, one red, one green, and one blue. Each picture element is an actual physical point in an image. The more points, the better the image quality. There is a trend happening in today's LED marketplace to develop bigger screens at a lower cost, and manufacturers are constantly searching for ways to tell clients they have a product that has a certain quality but costs less. Unfortunately, this is done by cutting some corners, and the buyer should be aware that this is happening. It's important to distinguish real pixels from virtual pixels. Virtual pixels, sometimes called pixel sharing, were conceptualized as a cost savings measure. The logic is very simple. Diodes are the most expensive component of an LED display. So, if you can make a display with fewer diodes, the display costs less to make. There are 2 ways to reduce the number of required diodes. First, make a smaller display. Or second, modify the diode configuration and allow diodes to contribute to multiple pixels. In essence, a pixel can borrow green from a neighboring pixel to its left and borrow red from another pixel to its right. This does cut down on the number of actual pixels needed to create an image, but it results in a poorer image quality. It is essentially overlapping or duplicating the use of pixels instead of physically adding more actual sources of light. The virtual pixel term can lead the customer to believe that there is 1 pixel every 15 millimeters in the display. This is simply not true. It's important to note that true pixel density is a critical factor in image quality of an LED display. These pixels are actual physical points of light, and the more there are, the higher the resolution, and therefore a better quality of picture. A virtual pixel will share pixels in a mesh-like pattern. A display that is built with true one-to-one pixels will have a light point for every pixel. There are multiple electronics marketplaces that are competing to create the highest resolution screen. Cell phones, tablets, laptops, and televisions are good examples of manufacturers racing to create the best possible screen image. However, none of these displays are using shared or virtual pixels to deliver a quality image, because vendors know that these methods do not create the best image. The LED video board business, unfortunately, does employ this shared pixel methodology, and the result is a poorer image. The advantage may be a lower sales price, but in the end, the picture quality is not as good. All the advancements in electronic display quality have come from adding actual physical pixels. It's important to note that software optimization can provide some minor improvements, but it does not actually increase the resolution of the screen. In summary, it is important that the buyer understand the true resolution of the product they are considering and compare it to the true one-to-one pixel display. While the price may be lower, with a virtual pixel product, the cost will be quite evident in loss of picture quality.